Good morning, students. In our previous video, you learned what is a decimal fraction, how to express a decimal fraction as a decimal numeral, and also place value chart of decimals, how to compare them, and many more. And in this video, you are going to learn how to perform the 4 fundamental operations on decimals. That is addition, subtraction, multiplication, and division. Now let us start with addition. Addition. So how to add decimals? Let us see through one example. Add the following. Add the following. A. 53.484, 5.9, 0.834, 7. And B. 16, 16.823, 14.58, and 9.2. So whenever you want to add 2 or more decimals, what you have to do is arrange the decimals one below the other in such a way the decimal points fall in one line and add as you add in natural numbers. Let us see how to do it. Solution A. Now we want to add 53.84, 484, 5.9, 0.8347, 47. So if you notice, all the decimal points fall in vertical line. As a result of this, place values are aligned in one line. All 10 places in one line, in one column, all 100 places in one column, and so on. Now add as usual. 7, 4 plus 4, 8, 8 plus 3, 11, 5, 14 plus 8, 22, 2, 5 plus 5, 10, 1, 60.2187. So this is how we add decimals. Now if you notice here, some blank spaces are there. In the second decimal, there is no 10th and 100th places. Whereas in the first decimal, there is no 1000th place. So if any of you have confusion, you can convert all into like decimals as I am showing here and can add them. That is 53.4840, as there is no 1000th place in this. In the second decimal, only 5.9. That is no hundreds, no thousands, no 10,000s. And last one, 0.8347. And add all these, and again there won't be any difference. You get the same answer, 60.2187. So you can add any decimals, any number of decimals, 2 or more decimals in this way and find their sum. Now let us see quickly the example B also. So in B, first let us write 16.0 and 16.823 and 14.58 and finally 9.2, and add all these 3, 10, 9, 14, 16, 1, 7, 13, 17, 26, 2, 3, 4, 5. So this is how we add 2 or more decimals. Now, next. What is the next topic? Subtraction. Next operation is subtraction. Let us see how to subtract decimals. Subtraction. Now I told you in case of addition, it is your choice whether to convert them into like decimals or not. But it is not the case in subtraction. You have to convert them into like decimals and you have to subtract. Let us see again one example. 2. Find the difference between 100 and 63.4792. Now here clearly 100 is the bigger one and 63.4792 is the smaller one. Therefore, first we have to write 100. But in the decimal which you are going to subtract, there are 4 digits after the decimal point. But you don't have any decimal digits in 100. So that is why we write this 100 as 100.0000 and then down 63.4792 and then we do the subtraction. If you don't convert like this, it is not possible. It becomes difficult for you to do the subtraction. So in case of decimals subtraction, you have to convert both into like decimals and perform subtraction. Now we'll have to borrow from here. When you borrow 1, it will become 10 here, and from that 10 if you borrow 1, 9 here, again 9 here, again 9 here, again 9 here, it will be 10. Now 10 minus 2, 8, 9 minus 9, 0, 9 minus 7, 2, 9 minus 4, 5, 9 minus 3, 6, 9 minus 6, 3, and this is borrowed already. So this is how we perform subtractions in decimals. So what you have to remember is, while performing subtractions in decimals, you have to convert both into like decimals and then only you have to perform the subtraction. So after subtraction, what is the next operation? You all know very well, and it is multiplication. So let us see how to perform multiplication in decimals. Multiplication. How to perform multiplication in decimals. So example 3. This also we'll do through an example. Find the product of 68.34 and 2.7. So clearly product means we have to multiply. Product means what we have to do? We have to multiply. So I'll write 68.34 into 2.7. And while doing multiplication in decimals, what we do is, first we multiply the numbers as if there is no decimal point. That is, I multiply 6834 into 27. If you notice, I haven't kept any point here. Just I multiply both. So 7 4s 28, 2, 7 3s 21 plus 2, 23, 7 8s 56 plus 2, 58, 5, 7 sixes 42 plus 5 47. Now when you multiply with 2, 2 fours 8, 2 3 6, 2 8 16, 2 sixes 12 plus 1 13. So add 8, 11, 15, 14 and 8, 1. So this is the product of these two numbers without point. Now what you have to do is to decide after how many digits you have to keep a point. Here see, in the first number we have a decimal point after 2 digits. Whereas in the second number we have a digit, after 1 digit you have a decimal point. Once again, in the first number we have 2 digits after the decimal point, and we have 1 digit after the decimal point in the second number. So 2 plus 1 3. 2 plus 1 3. Therefore, you have to keep a decimal point after 3 digits in the product. So this answer will become now 184.518. So if you notice, point after we have 3 digits. Why? Because in the numbers which we multiplied, in the first number we have after point 2 digits, and in the second number we have 1 digit after the decimal point. So total 3. So you have to keep a point after 3 digits counting from right to left. So this is how we multiply decimals. And another important point is there to learn. That is, multiplication of decimals by numbers like 10, 100, 1000, etc. is very easy. There is no need to do much calculation. And what the rule says is here, when you multiply a decimal by numbers like 10, 100, 1000, 10,000, etc., the decimal point moves towards right. As many digits as the number of zeros in the number with which you are multiplying. So let us see these examples. First one. You are multiplying 0.74683 by 1000. So now in 1000 you have 3 zeros. Therefore, the decimal point moves right side 3 digits since the number is having 3 zeros. So this point comes up to here. So this becomes simply 746.83. Similarly, if you multiply 1.582 by 10, the decimal point moves right side now by only 1 digit. Why? Because there is only 1 zero in the number with which you are multiplying. So this becomes 15.82. And keep in mind, we can do like this only when you have zeros only after 1. That is powers of 10. 10, 100, 1000, 10,000, etc. only. Okay, now let us see one more example. 548.23 into 1000. So now the decimal point has to move right side by 3 digits. My God, but we have only 2 here. So what about the third digit? So what we'll do is, for 2 zeros, this point moves up to here. That is, this becomes 54823. And 1 zero is left, and that additional 0 will come here. So this is how we do multiplication of decimals by numbers like 10, 100, 1000, etc. In such cases, what happens? The decimal point moves towards right as many digits as the number of zeros in the number with which you are multiplying. In the first number, we are multiplying with 1000, 3 zeros are there, so the decimal point moved right side by 3 places. In the second number, we are multiplying by 10, so the decimal point moved 1 place right side. And in the third number, again we are multiplying by 1000, 3 zeros are there, so point should move right side towards right 3 digits, but there are only 2, therefore that extra 0 came there. So this is how we do multiplication of decimals. And now let us come to division. Division. Again, in this division, you have different cases. One is division of a decimal by a whole number. Division of a decimal by a whole number. And the second case is division of a decimal by another decimal. So let us see each case through examples. Example 1. Divide 18.498 by 4. Okay. So division is, what is the division sentence we have to write here? 18.498 divided by 4. So that means you have to divide 18.498 by 4. And this is just normal division only. The division process is as we do it in natural numbers, in the same way we do here also. But what care you have to take is, when you are bringing down a digit after the decimal point, you have to keep a point in the quotient also. That's it. So first in 18, 4 table 4 times. 4 4s 16, remainder 2. Now we are bringing down a digit after the decimal point 4. There is no need to keep any decimal point here. But since you took a digit after the decimal point, keep a point in the quotient. Now in 24, 6 4s 24. Now 0. We bring down 9. In 9, 4 2s 8. Remainder 1. We bring down 8. And in 8, 4 4s 16. Remainder 2. And we can keep 0 and 5 4s 20, 0. So you may get doubt, sir, why did you keep 0? There is no 0 there. Yes, any decimal, for any decimal, you can keep any number of zeros you want at the end. For example, 5.43 is there. If you need, you can keep 0, 0, 0, 0, as many zeros as you need. So that is why here those are invisible zeros. you can't see them, but there are. So 1 0 we brought down and the remainder became 0. So the quotient is how much now? This answer is 4.6245. So this is division of a decimal by a whole number. Here if you notice, 18.498 is a decimal, whereas 4 is a whole number. So this is how we divide a decimal number by a whole number. Now let us see how to divide a decimal number by another decimal number. By another decimal number. That is, for example, 0.589 divided by I'll say 0.25. So here it is not possible to do the division, to perform the division easily with a decimal. So what we do is, to make it easy, we convert the divisor into a whole number. So for that purpose, what I do is, first I write the given division in the form of a fraction. We all know A divided by B is nothing but A by B. So 0.589 divided by 0.25. Now here this 25 must be changed to 25. It must be changed to whole number. So the only possibility is it must be made 25. So to make it 25, we use the rule just now we have learned. If you multiply any decimal by numbers like 10, 100, 1000, etc., the decimal point moves right side as many zeros, as many digits as the number of zeros in the number. So here we have 2 digits. So if the decimal point comes from here to here, this becomes 25. So for that, the decimal point has to move 2 digits. That means this must be multiplied by 100. But in a fraction, you can't multiply only denominator. You have to multiply both numerator and denominator. So let us multiply this also by 100. Then this becomes, since you are multiplying by 100, this becomes 58.9, because point moves right side only by 2 places. And here this point moves by 2 places, so it becomes 25. Now you divide 58.9 by 25 as usual, because this came under the first category now, division of a decimal by a whole number. So now 25, 2 25s 50, remainder 8. We are bringing down a digit after the decimal point, so we will keep a point. 3 25s 75 and remainder 14. I told there are many zeros. I will bring down 1 0, 140, and this becomes 5 25s 125. The remainder is now 15. And 1 0 I will bring down 6 times 150 and 0. So this is how we divide a decimal by another decimal. Now, one more. Again, division of decimals by numbers like 10, 100, 1000, etc. is again easy, as we did in case of multiplication. Here also, if you happen to divide a decimal by numbers like 10, 100, 1000, etc., that division is very simple. So let us see how to do it. The rule is, if you divide a decimal by numbers like 10, 100, 1000, 10,000, etc., now the decimal point moves left side. In case of multiplication, the decimal point moves right side, whereas in case of division, the decimal point moves towards left. Same, as many places as the number of zeros in the number with which you are dividing. So let us see some examples. Example and 1. If you divide 2.583 by 10, in 10 there is 1 0. So the decimal point should move left by 1 place. That is, it becomes 0.2583. So whenever there is no whole part, it is customary to place a 0 in place of whole part. So this becomes 0.2583. Now suppose you have to divide 1.58 divided by 1000 or 10,000. Now what happens? You have to move the decimal point left by 4 digits. But there is only 1 digit available. So the remaining 3 digits you have to keep 0. That is 0.000153. So this is how we divide decimals by numbers like 10, 100, 1000, etc. Now, the last concept which we have to learn for the coming FT in this is changing a decimal into a fraction. Changing a decimal into a fraction. In fact, this is not the last, still one more is there. Into a fraction. So how to change a decimal numeral into a common fraction? That is what we are going to learn now. Now this also we'll do through examples. Let us see first one. 5.78. So whenever you want to write a decimal as a common fraction, what you have to do is Remove the decimal point and write the resulting numeral as numerator. That is, if you remove decimal point here, this becomes 578. So that we write as numerator by, in the denominator, we write as many zeros after 1. After 1. In the denominator, after 1, we write as many zeros as the number of digits after the decimal point. So in this particular case, after the decimal point, you have 2 digits. So 1 after, you have to keep 2 zeros. And if there is any possibility for cancellation, you can put it in lowest terms. That is, 2 table goes in both 289 times and in this 50 times. So the final answer is 289 by 50. So this is how we convert a fraction into a decimal. Now here one small trick is there. When you want to express, suppose you want to write 2019.75, you are asked to write as a fraction. So here what happens, if you write this in the usual process by removing the point and 201975 by 100, like this, 201975 by 100, the numerator becomes very big and the cancellations will become little tougher for you. So to avoid that, what you have to do is keep the whole part intact. Don't touch the whole part. That is, write 2019 as it is. And now 0.75, that can be written as 75 by 100 as a fraction, because point after 2 digits are there. So we removed the 0.75, 1 after 2 zeros. Now 25 table 3 times, 4 times. Now this conversion into improper fraction is very simple. If you multiply 4 and 2019, you get 8076 plus 3, 8079 by 4. This is not as complicated as the cancellation here. Of course, if you are good at tables and calculations, you can do anything very easily. But to avoid any confusion, it is better not to touch the whole part when you are converting it into a decimal. So this is how we convert a decimal fraction into a common fraction. Now, next one. A common fraction into a decimal fraction. That is reciprocation. Conversion of changing or expressing a common fraction. Expressing a common fraction. Common fraction as a decimal. Expressing common fraction as a decimal. Let us see this also. Example. Express 3 by 4 as a decimal. As a decimal. Now, before going to say this, whenever you are changing a common fraction into a decimal, sometimes you get a terminating decimal, sometimes you get a non-terminating recurring decimal or non-terminating repeating decimal. I'll tell you about both these little later, but let us see what we get here. So whenever you want to convert a common fraction into a decimal, the only thing is numerator must be divided by the denominator. Don't keep in mind big number must be divided by the small number. No. Numerator must be divided by the denominator. Numerator must be divided by the denominator. Whichever is big, we don't mind. So here numerator is 3 and denominator is 4. So we have to divide 3 by 4. As you know, every whole number can be expressed as a decimal by keeping point and any number of zeros you want. Though you can't see here 3 point, many zeros are there after that. So I'll keep 10 for convenience now. Now let us see. 4 can't divide 3 even one time. Therefore, it goes 0 times. 0. Now we take a digit immediately after point in the beginning only. Why? Because 3 is smaller than 4. So now the number becomes 30. So in 30, since we took a digit after point, keep a point here. 7 4s 28, remainder 2, and again 0, 20, 5 4s 20, remainder 0. Therefore, 3 by 4 equals 0.75. So in the process of converting a common fraction into a decimal, if the remainder becomes 0, the decimal so obtained is called a terminating decimal. That is, the process of division stops after some time. So here, after doing some division, the remainder became 0 and the process ended. So if that is the case, the decimal obtained is called a terminating decimal. Now let us see the other case. Now I'll take one more example. Convert 2 by 3 as a decimal. So now also the same. You have to divide 2 by 3. So 0.0, so on. Into 3 can't go. So 0. First only we are taking a digit after point 20. So 0.63 is 18. Remainder 2. And we can bring 0. Again 63 is 18. Remainder 2. 20. Again 63 is 18. Remainder 2. If you continue this division, as long as you study, the remainder will never become 0. You'll have to continue to do the division, that's all. That is, here the process of division is not ending. Therefore, this type of decimals are called non-terminating recurring decimals or non-terminating repeating decimals. Here, the process of division is not ending. So why we are stopping here? Because we found some repetition. So we will keep dots. These dots suggest the division is not completed. We stopped since we found some repetition. Now you can write, therefore 2 by 3 equals 0.666, so on. So how many sixes are there? Infinite, many. Now there is a special notation for this. That is, what is the part repeating here? 6 is repeating. Therefore, we write that 6 only one time and keep a bar over it. So 0.6 bar means 0.6666, so on. And what is this type of decimal? This is a non-terminating recurring decimal. Non-terminating recurring decimal. Or you can call it also non-terminating repeating decimal. Now, again for this non-terminating recurring decimals, there are 2 parts. I will tell them. Now that is, in a non-terminating recurring decimal, the recurring part is called its period. And the number of digits present in the recurring part is called its periodicity. Now, for example, see, 1. You have 5.27481 bar. So, after the decimal point, there is no rule that all the digits must repeat. Here, in this 27 is not repeating, only 481 is repeating. So, period of 5.27481 is equal to 481. Why? Because it is the part that is repeating. 27 is not repeating. So the recurring part, the repeating part of a non-terminating recurring decimal is called its period. And the number of digits present in the recurring part is called its periodicity. So periodicity of 5.27481 is equal to, how many digits are there in recurring part? 3. So that is the recurring part 3. Okay, so this is how we convert a decimal, a common fraction into a decimal. Now one more last point, this is, without doing all this, how to check whether a given fraction represents a terminating or non-terminating recurring decimal. For this, the rule is, if the denominator of a fraction in its lowest terms has no factors other than 2 and 5, then it represents a terminating decimal, or else it represents a non-terminating repeating decimal. Now let us see. For example, you want to check whether 7 by 40 represents a terminating decimal or non-terminating recurring decimal. First, check whether this is in simplest form or not. Yes, it is in simplest form. Then find the factors of the denominator. The factors of the denominator, factors means prime factors. 2 into 2 into 2 into 5. So the factors of the denominator are only 2 and 5. Therefore, 7 by 40 represents a terminating decimal. Represents a terminating decimal. 7 by 40 represents a terminating decimal. If you find any factor other than 2 and 5, it represents a non-terminating recurring decimal. In the denominator, you can have any number of 2's and any number of 5's. You can have only 2's or only 5's, but you shouldn't find any other number. For example, see this one, 14 by 21, 28. Oh no, 14 by 28 means it is not in simplest form. 14 by 15, let us take this. Now it is already in simplest form. Now if you find the factors of denominator, 15 equals 3 into 5. So other than 5, you find one factor 3. Therefore, 14 by 15 represents a non-terminating recurring decimal. Non-terminating recurring decimal. Okay, so that's all, and with this we conclude your FT portion. So prepare well. Thank you.